This is a continuation of the 3.2 video, which was on reciprocals of quadratic functions. Okay, so what we're going to do is in this video go over some examples so that we can do like a full analysis of what a reciprocal of a quadratic looks like in all of its entirety. Okay, so before we get into that, I do want to note that if you have any reciprocal functions of quadratics and you have two zeros or two x-intercepts, the graph itself will look like three different parts: a left-hand side, a right-hand side, and a middle part. That middle part has something that looks like a parabola inside, so you might get a max or min point inside the middle of this graph. That parabola is usually equidistant, or in other words, halfway between the two vertical asymptotes. Okay, so let me just show you what I mean. If we have two different roots, which give rise to two different vertical asymptotes, your graph might look like this, where you have the red parts, two L's, okay, and kind of like a U in the middle. So this was the parabola that I was talking about. So the two L's are your left-hand and right-hand side of the graphs, and then you have a middle part, which is where the parabola exists. So I know it doesn't really look like a parabola, but it's just a very angular parabola. That parabola will have a max or a min right in the middle of your two asymptotes. So this guy could have a minimum if, let's just say, the L's were flipped to the bottom and then that U was flipped to the top. So you might have a minimum point if your parabola was going this way. All right, so let's show you an example of several different kinds of questions. So the first one is the most basic. They're going to give you an equation that's a quadratic, and then they're going to say graph it. So tell me all these different things like your domain, your range, your asymptotes, maybe some x and y intercepts, and then you're going to sketch the whole thing. Okay, so what you want to do first is, why don't we tackle the domain and the vertical asymptote. Okay, so this is what's going to tell you about your domain and the vertical asymptotes. And you know what, once we do that, we can actually figure out the horizontal asymptotes, which will then tell you about your range. So take the domain, or the denominator, and then factor it. And these two numbers, the opposites, will be those restrictions. Okay, those guys will give rise to your vertical asymptotes, which are here and here. And those guys go into your table. Okay, so you're going to have -3 from the right and left. You're going to analyze 5 from the right and left. And we don't really know this answer yet. We actually have to figure it out by putting the positive and negative infinity into the table as well. So once you get your answer, this answer is going to be your equation for your horizontal asymptote. Okay, so you kind of do it the same way we did before. Choose a number that is near -3 from the right-hand side. So let's just say -2.9. Put it into the equation wherever you see an x, so here and here. 5 divided by -2.9 minus 5 times -2.9 plus 3, that's going to give you a certain y value. And in my experience, it seems like it was a really negative number. Okay, so I just put negative infinity, and I did the same to the rest of them, and I got all these answers. So I might have chosen -3.1 here, which is a little bit to the left of -3, and then maybe 5.1 for this guy and 4.9 for that guy. So you're just subbing all those numbers into the original equation and seeing what happens. Okay, if we wanted to actually describe that behavior, we could always say, as x approaches -3 from the right, y is going to approach -infinity. So just in terms of the red, let's show you already what the graph is starting to look like. So we said if we were approaching this vertical asymptote of -3 from the right-hand side, so this guy, we chose -2.9 to sub into the equation, and we got a super negative number. So that means that our graph should be going downwards. When we subbed in -3.1, we got a super positive number, which means our graph should be going upwards here. Just like when we did the analysis for the 5s, 5 from the right was going towards a positive infinity. So notice that it's hugging that red line from the right-hand side upwards. And this one is hugging it downwards from the left-hand side. Okay, now I subbed positive and negative 1,000 separately into the equation. So when I put in positive 1,000, I got 0, but a positive 0, like positive 0.0001 or something like that. So I said that that was from above 0. So the dot for positive 1,000 might be somewhere up here. Okay, versus say this one, if I did negative 1,000 and put that into the equation, I still got 0 from above. So that means if I was all the way at negative 1,000, I'm just going to be very close to the x-axis, but from the top. So I'm starting to see that both the green arrows are approaching this line, but never touching it, and that's why we had the horizontal asymptote at y equals to 0. Okay, so I'm starting to see what my graph looks like, but we might want to do a little bit more analysis. I mean, we could always just continue this and join those lines. It doesn't have to be super accurate because, I mean, you can't really be super accurate unless, of course, you have graphing technology. But we can be more accurate here, I guess. We should maybe figure out x and y intercepts. So here's the analysis for the x and y intercepts. An x-intercept is where the y value is 0. So I subbed in a 0 for the y, and now I'm going to solve for your x. Well, if it's dividing by these two and I bring it to the other side, it will multiply the 0. But anything multiply 0 will become 0. So essentially all of this disappears, and I get 0 equals to 5. Well, that doesn't even really make sense. So we have no x-intercepts. That should actually make sense because if we look up here, don't you have a horizontal asymptote? So you don't have x-intercepts anyway. All right, now we're going to find our y-intercept, which is a little bit easier. You're going to plug 0 into your x's, and then you're just going to solve. So I got negative 1/3, which is about negative 0.3. Okay, and I'm going to show you my final graph. So negative 0.3 at an x value of 0 is right about there. So I do have a y-intercept, no x-intercepts. The last thing I might want to find is probably the peak, just so that we have an accurate graph. The peak is, remember, in between the two red lines, like right in the middle. So we should first figure out what right in the middle is. Take your two red numbers, so your two vertical asymptotes, and average them. Add them together, divide by 2. That gives you the y value that's right in the middle. Now to figure out how high your point actually is, you take your 1 as your x value and put it back into the original equation wherever there is an x. Figure out your answer, so then I get this point, 1 and negative 0.3125. Okay, so if I'm going to include that into the graph, here's 1, which is directly in the middle of both of these two walls, and then negative 0.3125 is a little bit higher than the purple dot. Okay, so this is about as accurate as you're going to get without graphing technology. Let's try another example. Okay, so this one's going to ask us for increasing and decreasing slopes. Okay, we're going to have to do the analysis again. Oh, look, they actually they factored the bottom for you, so that makes it easier to figure out your vertical asymptotes. All right. Let's do the analysis. So you have negative 2 from the right and the left, 5 over 2, which is about 2.5 from the right and the left, and then to figure out this guy, you need your positive, negative infinities. So you guys know how to figure all of this out again, and I'm just going to put it all together into a graph. Okay, so before I start graphing, I might start, I mean, it's up to you what order you go in, but you can always draw this stuff first and then do the max or min analysis, but it's really up to you. So why don't I show you, here are your two vertical asymptotes at negative 2 and 2.5. I have the end behaviors on either side, and I also have my end behaviors for the horizontal asymptote, which I had found out to be 0 before. Now if I join everything together, it looks like those L's are down here, which means your U is up here this time. Okay, now your U, since it's up here, I'm going to get a minimum point, and that's why when I decided to find it, I mentioned it was a minimum. So the minimum is going to be between your two vertical asymptotes. Add those two together, take the average and divide by 2. This is your x value, so that's going to go there in your minimum point. And then you take this number and put it into your equation where the x's are, and you calculate your y value for your minimum point. So 0.25 and 0.3 looks like it's about here. So this just makes our graph a little bit more accurate. All right. Now in terms of the slope, so that's basically what the question asked for at the very beginning. What I'm going to do is I'm just going to get some lines out in certain colors, and I'll start to show you because this takes a little bit of understanding. How do you know if it's increasing or decreasing slope? Okay, so in this region only, we can draw either secant lines or we can draw tangent lines. It really doesn't matter. And what you're going to do is just analyze the slope. So this slope might be, I don't know, -5. This one is a steeper negative, so -8. Maybe this one is even more negative, so -11. If you're getting more and more negative, it's a decreasing number, and that's why your slope is decreasing. This one goes, okay, so this region right here, you're going from, maybe this is a +11 slope, and this is less steep, so +8. Maybe this is +5. So even though they're all positives, the positive numbers are decreasing. And again, that's why you have a decreasing slope. This guy right here, let's use the color orange. Okay, on this side of the parabola, you have a negative, less negative, negative, but even less, and then all of a sudden you have a 0. And from the 0, you start having positive slopes. So throughout the entire thing, negative to less negative to positive means that the entire parabola here has increasing slopes. Okay, so what I've done here is I've just written down it's increasing between this region. It doesn't count -2 and 2.5, so make sure you have your round brackets. And then it's decreasing at the two L's. Okay, so again, those are those two regions, and you're not including the asymptotes, the vertical asymptote numbers. Okay, now the very last example is where you actually have one that looks a little bit different. So notice that I don't have, like I can't solve for x here, so no vertical asymptotes. If I start to put in numbers, like I don't have any red numbers to put into my table, so I'm just going to analyze for my horizontal asymptote, and I actually do get a horizontal asymptote. So I might get a graph that looks a little bit like this. So you see how I don't have any vertical asymptotes, but I do have this horizontal asymptote right here at 0. Okay, now how did I get this hump? Well, what I'm going to do is I'm going to start looking for any x and y intercepts. So an x-intercept, again, is when your y is 0, you bring this over and it disappears. And that should make sense that we have no x-intercepts. But when we do have the y-intercept, we're going to put the 0 into the x, and we're going to solve. So I got 0 and about 1.5. So I know that it looks like this guy, which is this one that I showed you in the previous video. Okay, so that's how we do the full analysis for each of the different types of reciprocals of quadratic functions.